Hi friends, in this tutorial series, we'll be implementing examples using Spring Boot 3 security. In this tutorial, we'll be implementing basic authentication using Spring Boot 3 security. So we'll be looking at the inner workings of Spring Boot 3 security when implementing basic authentication and also which all Spring security filters are involved when implementing this. For this, I'll be taking reference of my website javanews.com. So go to Spring Boot 3. In Spring Boot 3, go to Spring Boot 3 Security. In Spring Boot 3 Security, the example that we'll be implementing today is Spring Boot 3 Security MySQL Basic Authentication. So go to this example here. In a previous tutorial, we implemented Spring Boot 3 Security Authentication simple example. You can go to this tutorial here. So in this tutorial, we saw the internal working of Spring Security in detail. So in this tutorial, we looked at what happens when we add the Spring Security dependency to our project. So when we add this dependency in the filter chain, various security filters, they get triggered, and using this, the Spring Security functionality gets implemented. So you can go through the YouTube video that I have given here. Also in another previous tutorial, we had implemented Spring Boot 3 MySQL CRUD example. So you can go to this tutorial here. In this tutorial, we created a Spring Boot application to perform CRUD operations using MySQL database. So we had exposed APIs using the REST controller, using which the user he can perform the CRUD operations. You can go through the YouTube video here. So for this tutorial, we'll be modifying the example that we had implemented for this tutorial to add basic authentication. So whenever the user he wants to perform CRUD operations using basic authentication, he will first need to authenticate himself by providing the credentials. Only then he will be able to perform the CRUD operations. Download the source code that we had implemented for this tutorial. Go below, Spring Boot 3 MySQL CRUD example, download this. Project that we just downloaded, it is a Maven project. So import it in Eclipse. Next, in the pom.xml, we have specified some dependencies. These dependencies are Spring Boot Starter Data JPA dependency and the Spring Boot Starter Web dependency. Next, we'll be running the pom.xml, so run as maven install. This will download the dependencies that we have specified in the pom.xml. So here the build it is successful. So let us run the Spring Boot project. So as we are performing CRUD operation on MySQL database, I have started the MySQL database using the MySQL command line tool. So here go to source main Java, and I'll be running this class run as Java application. So this will start the Spring Boot project. So here the project, it has started on port 8080. So using the browser, if I now go to the URL localhost 8080/employees, here it has retrieved the list of employees from the MySQL database. Next, we'll be modifying this project to implement basic authentication. So the user, he will first need to authenticate himself before he can access the controllers using which he will be performing the CRUD operations. In Spring Security, basic authentication is a very simple way to authenticate users based on the username and password. So when a user he tries to access a protected resource, they are prompted to enter their username and password. This information of username and password is then sent to the server in an encoded format. The server then compares this information to a list of valid username and password combinations to determine if the user is authorized to access this resource. If the username and password they match with the ones that the server has, then the user is granted access. If not, then the user is denied access. This is a very basic and commonly used method of authentication in web applications. So let us begin with the implementation part. So we'll be modifying the example that we had previously implemented for Spring Boot 3 MySQL CRUD example. The first change that we'll be making is we'll be adding the Spring Security dependency to the pom.xml. So go to Eclipse, and here to the pom.xml we'll be adding this dependency, Spring Boot Starter Security dependency. Build this project, run as maven install. Here the build it is successful. Next, for basic authentication, when the user he tries to perform a CRUD operation, the user will be asked for credentials. So whenever the user he will try to access the APIs exposed by the controller, he will be first asked for the username and password. So when he enters this username and password, using these credentials, a user object is created. So the user object with the entered username and password is created. Now at the Spring Security end, we have created another user object, and for this user object with Spring Security, we have configured the correct username and password. Next, Spring Security, it compares the user object with the entered username and password with the user object which has the actual username and password, and if they both match, then the user is granted access to the REST controller. If they do not match, then the user is denied access to this controller. Before we make any further code changes, let us first have a look at what is bcrypt encoding. Consider a scenario where client credentials such as username and passwords, they are stored in a database. Now it is crucial to protect this information from unauthorized access. Now suppose if the database it gets hacked or an employee he gets unauthorized access to this database, then they can potentially view the sensitive credentials, and this will lead to a security breach. To address this issue, one solution is to utilize bcrypt encoding. So using bcrypt encoding, we'll first be encrypting the credentials and then storing them in the database in a secure manner. So bcrypt encryption, it is a one-way process, meaning that the encrypted password, it cannot be easily deciphered. So suppose if the password is Java in use, then first I'll be encoding it using bcrypt encoder, and then I'll be storing it in the database. So even if any unauthorized person, if he uses this password, he will not know what the actual password is. Next, let us have a look at the online bcrypt encoder. So here we have the online bcrypt generator and validator. Suppose the password for which I want to generate the bcrypt hash is Java in use. Enter the number of rounds, so you can keep it any. There I'll keep it as 20. And here I click on generate bcrypt hash. So here the bcrypt hash, it has been generated for the text Java in use. So now instead of the password Java in use, we'll be storing this bcrypt hash in the database. So even if any unauthorized user he gets access to this database, they will not know what the actual password is. But in this scenario, how will Spring Security know whether the password entered by the user is correct or not? Because in the database, we do not have the actual password, but we have the bcrypt hash of the password. In case of bcrypt encoding, using the bcrypt hash, we cannot decipher back the original text, but we can compare the original text and the bcrypt hash, and bcrypt can tell whether this text is the one for which the bcrypt hash has been generated or not. So copy this, and here below I have the validator. So here I'll put the bcrypt hash password, and suppose if here I put here Java in use 1, check match. Here it is telling that it is not a match. The encrypted password is not the hash bcrypt of the plain text. Now suppose if I pass in here Java in use, so it is a match. The encrypted password is the hash bcrypt of plain text. So what Spring Security will do is it will compare the plain text and the bcrypt hash that is stored in the database. And if it is a match, then yes, the password entered by the user, it is correct. Next, we'll be creating the Spring Security configuration. So in this configuration, we'll first be creating a bean of type user detail service. In this user detail service, we create the user object. So if you remember previously, we have seen that at the Spring Security end, Spring Security, it creates a user object with the actual username and password. When the user, he enters some credentials, another user object is created and it is then compared with the Spring Security user object. So now we'll be creating this Spring Security user object. And we do this by making use of the user detail service bean. So in the user detail service bean, we are creating a user with a username Java in use, and the password, as previously discussed, we are making use of the bcrypt password encoder here. So we call the password encoder.encode method for the password which is Java in use, and we are giving read authority to this particular user. So once this user object has been created, we need to save this user object details. So currently we are not making use of any database to store this user object, but we'll be storing this user details in memory. For this, we make use of the in-memory user details manager, and using this, we will be storing the user details. Finally, we create a bean of type security filter chain. So here we specify that we want basic authentication for the HTTP request. Also, we configure that all the incoming HTTP requests, they are authenticated. So let us create the security configuration. Here in Eclipse, create a new class, security config. Package will be com.javanews.bootmysql.crud.config. Copy the contents of this class. Let us test the security configuration changes. Start the Spring Boot application. Here the Spring Boot application, it has started on port 8080. Now previously we could access the list of employees by going to localhost 8080/employees. So refresh this. So here it is asking us for credentials. So currently when we hit localhost 8080/employees, we did not provide any credentials and we got this prompt asking for credentials. So let us understand the Spring Security workflow. So when no credentials are provided by the user, Spring Security, it returns back a prompt asking for the credentials. So let us see what happens. So when the user, he hits the URL localhost 8080/employees without credentials, the first call is made to the filter chain. So in the filter chain, the Spring Security filters, they get called. So quite a few filters are called. We are not interested in all of them. So one of the call is made to the basic authentication filter. In this basic authentication filter, in the current call, we have not provided any credentials. So it just returns back the call to the filter chain. The filter chain then calls the authorization filter. Now this authorization filter, it is the last filter called by the filter chain. In this filter, we check if the previous filters, they have authenticated the user and populated the security context, so that Spring Security knows that yes, this request, it has passed the authentication and it can move forward. So in our cases, no authentication has taken place, so it will throw an exception. This exception is then caught by the exception translation filter. The exception translation filter then returns the dialog box asking for the credentials. So let us have a look at this flow. We'll be adding debug points to our Spring Security application. I'll first be adding a debug point to filter chain proxy. Filter chain proxy, go below here. So in the do filter method, I'll be adding a debug point here. Let us start the Spring Boot application. debug as Java application. So I am starting it in debug mode. So refresh this. So again, we are not passing any credentials. So here we are inside the filter chain proxy and start. So now we are in the debug window. At the filter chain, it will call the disable encode URL filter. You're not interested in this. The next filter is the web async manage integration filter. Next is security context holder filter, header writer filter, cause filter, CSRF filter, the logout filter, basic authentication filter. Now we are interested in this. So you go to this filter here. So add a debug point here and run this. So here we are inside the basic authentication filter now. So here currently we have not passed any credentials. So the auth request, it will be null. And here we'll just return back. The next filter is a request cache aware filter, security context aware filter, anonymous authentication filter, exception translation filter. And next is the authorization filter. As told previously, this is the last filter that gets called by Spring Security, and in this we check if the previous filters, they have authenticated the request or not. Here I'll be adding a debug point. Let us run this. We are in the authorization filter. So let us move forward. So here in the authorization filter, it checks if the previous filters, anyone has authenticated it or not. So here it is showing that the authorization decision, it has still not been made. So the previous filters, they have not authenticated this request. So here it will throw this access denied exception. In the authorization filter, it will throw this access denied exception. It will get caught by the exception translation filter. So in this exception translation filter, we'll be adding a debug point in the catch block. Let us now run this. So here we are inside the exception translation filter. In the exception translation filter, we'll then be handling this exception here, handle Spring Security exception. In the handle Spring Security exception method, currently we are dealing with access denied exception. So it will come here in the else if block, and in handle access denied exception method, it will go here. In the handle access denied exception, we call the method send start authentication, and in this method we have an exception, insufficient authentication exception, that is full authentication is required to access this resource. So in the send start authentication method, using the authentication entry point dot comments, the request, it is sent back to the user asking for the credentials. Next we'll be looking at the scenario where wrong credentials are provided by the user. So in the prompt where the user, he has to enter the credentials, the user enters the wrong credentials here. So let us look at the scenario. The user, he hits the URL localhost 8080/employees with the wrong credentials. So this request, it goes to the filter chain. From the filter chain, various filters are called. The filter that we are interested in is the basic authentication filter. So this basic authentication filter, it makes use of the DAO authentication provider to authenticate the user. So what the DAO authentication provider does is that the user object that is generated from the credentials entered by the user is compared with the user object that we have in memory. So both of these will not match. So it will throw a user not found exception. So this exception, it is caught by the basic authentication filter, and it asks the client to enter the credentials again. So let us implement this scenario. So here in the prompt, I'll enter some wrong credentials. Can't sign in. So I've added the debug point in the filter chain proxy. So the first filter is the disable encode URL filter. We are not interested in this. Let us move forward. Header writer, cause filter, SRS filter, logout filter, the basic authentication filter. So here we are in the basic authentication filter. Now the basic authentication filter, it will see that it has the auth request which has the credentials. That is, these are the credentials that are provided by the user. So what this basic authentication filter does is that it makes use of the DAO authentication provider. So in the DAO authentication provider, if we go to the abstract user details authentication provider, we have the authenticate method here. Go here. If you now run this, here we are in the authenticate method. So in the authenticate method, we'll be comparing the credentials of the user object along with the Spring Security user object. So here we try to check if a user, it exists corresponding to the username that has been entered by the user. So if we go to the DAO authentication provider, here we have the retrieve user, it will come here. So here in the user detail service, we do not find the user corresponding to this username. So it throws an exception. So here the username not found exception will be thrown from the DAO authentication provider. This exception, it will be caught by the basic authentication filter. The basic authentication filter then will make use of the authentication entry point dot comments to send the request back to the user asking for correct credentials. And we will be looking at the scenario where the user he enters the correct credentials. So let us have a look at this scenario. So the user he will hit the URL localhost 8080/employees with the correct credentials. This request it goes to the filter chain. The filter chain it calls other filters, and one of these filters is the basic authentication filter. The basic authentication filter it makes use of the DAO authentication provider to authenticate the incoming request. This authentication it will be successful, and the flow it will go back to the filter chain. The filter chain then calls the authorization filter, which is the last filter in the filter chain. In this filter we check if one of the previous filters it has successfully authenticated the incoming request or not. Since this incoming request it has been already successfully authenticated using the basic authentication filter, so the authorization filter returns back to the filter chain successfully, and finally the user he is able to access the controller successfully. So let us implement this scenario. Now we'll enter the correct credentials, that is Java in use and password is also Java in use. Click on sign in. So here we are inside the filter proxy chain. Run this till we go to the basic authentication filter. So now we are inside the basic authentication filter. The basic authentication filter it calls the authenticate method of the DAO authentication provider. Here we will be retrieving the user corresponding to the username Java in use. So the user is retrieved successfully. Here additional authentication checks I will be adding a debug point. So here the user he will be authenticated, that is the passwords will be checked. So the authentication it is successful now. So we are back in the basic authentication filter. So here now in the context we are setting the authentication result to verify that this request it has been authenticated successfully. So let us run this. Next we have the authorization filter. So in the authorization filter we check if the authorization decision it has been made or not. So in this case it will be true. So if we now run this, we go back to the browser. Here we are able to successfully get the employee list. So we can hit the controller successfully. Currently for this example, we had hard-coded the username and password here. Now we'll be modifying this example to get these credentials from the MySQL database. Next we'll be creating a class named DAO user, which will be having the entity annotation, which says that this is a JPA entity. And also it makes use of the table annotation to say that this data it is corresponding to the user table in the MySQL database. It has the fields ID, username and password. So ID it will be a generated value, whereas the username and password will be retrieving it from the columns named username and password of the user table. So let us create this DAO user class. So go to Eclipse, here go to entity package, create new class DAO user, finish, copy this content. Next we'll be creating a repository named user repository, which extends the JPA repository. The entity for this JPA repository it is of type DAO user, and the primary key it is integer. Also for this user repository here we have defined a custom query method named find by username. So this takes the username and returns back the corresponding DAO user. So let us create this user repository. Go to Eclipse, go to the repository package, and you create a new repository. Copy the contents of this class. So previously we have seen the DAO authentication provider, which is used by the basic authentication filter for authentication. The DAO authentication provider it has a method named retrieve user. Inside this method we have a user detail service using which we load the user by username. So this user detail service it is provided to us by Spring Security. Now we want to write our own user detail service where whenever this load user by username method is called, we'll be loading the user from the MySQL database. We'll be creating a class named user detail service IMPL, which implements the Spring Security user detail service, and we override the load user by username method of the user detail service. To this load user by username, we pass the username corresponding to which we want to load the user. So in this class, we have also auto-write the user repository that we had just created. So in the load user by username method, we retrieve the user corresponding to the username by making use of the user repository, which fetches these details from the MySQL database. So we get a DAO user. From this DAO user, we create a new Spring Security user and return it back. Let us create this user detail service IMPL class. Go to Eclipse. Here in the service package, create a new class. user detail service IMPL. Copy the contents of this class. Finally, we'll be modifying the security configuration class that we had created before. So in this class, we'll be auto-wiring the user detail service IMPL that we just created. Also in this class, we'll be creating a bean of type authentication provider. So we want authentication provider of type DAO authentication provider. To this DAO authentication provider, we'll be passing our own instance of user detail service that we have just implemented so that it fetches the user details from the MySQL database. Also, we pass the password encoder as the bcrypt password encoder, and we return back this authentication provider. So let us make these changes. Copy this auto wire. Go to the config, security config. So I will be adding this. Also, we no longer need this in-memory credentials that we had set. Next, copy this bean. So these are the only code changes required. Let us start the Spring Boot application. So here it has started successfully. Before we test the basic authentication, we need to insert the user in the MySQL database. So for this, we'll first need to go to MySQL database and use this command, use Java and use DB. So we'll first need to select the database. The name of our database is Java and use DB. So this Java and use DB, it has a table named user which has been created for us by JP entity. So if you do a select star from user, currently there are no records. So we'll be inserting in this user table the username and password. So the username, it will be Java in use, and the password, it should be a bcrypt of the password. So if we go to this online bcrypt encoder here, so here suppose if I want to keep the password as Java in use only and do a generate bcrypt hash, so I need to store this as the password in the MySQL database. So let us first copy this, go to the MySQL database, and here I'll copy this bcrypt hash value. So here we have inserted the record. So let us now test the URL localhost 8080/employees. So here the credentials will be entering it correctly, Java in use, Java in use. So here we are in the filter chain proxy. So run this to we go to the basic authentication filter. So here we are inside the basic authentication filter. The basic authentication filter then makes use of the DAO authentication provider. We are inside the DAO authentication provider now. So here we retrieve the user. So this user detail service, it will call the load user by username method. So let us also add a debug point in the user detail service IMPL method. It will come here. So here it will retrieve the credentials from the MySQL database. We are returning back the user. So we have retrieved the user from the MySQL database. Next, it checks the password and they will match. So the authentication, it will be successful, and we come back to the basic authentication filter where the security context is set so that we know that it has been successfully authenticated. So here we are able to get the list of employees. Hope you have understood this tutorial. We'll be further modifying this basic authentication example to implement JSON Web Token. You can download the source code from here. Thank you.